What's up guys? Welcome back to another video. Today we're going to be going over LeetCode number 994, rotting oranges. We were given an n by n grid where each cell can have one of the following three values. 0 is an empty cell, 1 is a fresh orange, 2 is a rotten orange. Every minute, any fresh orange that is 4 dimensionally adjacent to a rotten orange has become rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1. So as you can see, an example here, there's one rotten orange. Each of its neighbors become rotten, and then as the minutes go on, you eventually have minute 4 where all the oranges are rotten. So you would output 4. A high-level approach for this would be to first realize that we have to use breadth-first search because we want to update the status of every rotten orange's neighbors and not just go down, I guess, the lineage of one rotten orange is neighbors and not update the other ones prior to that. So once we have that in place, we can start formulating a way to execute this breadth first search algorithm. And to do that, what we have to first do is tally the number of fresh oranges because we need to know when to stop execution of it. And then we also have to add the location of the rotten oranges to a queue. So in addition, we have to initialize a minutes variable to 0 and now we can run breadth first search while the queue is not empty and fresh is greater than 0. So what we can do now is use a for loop to iterate through the starting length of the queue upon execution and pop from the left. Once we do this, we mark all neighbors of each orange that are still fresh as rotten, and then add them, i.e. their locations, to the queue. Prior to adding though, make sure you subtract from fresh each time you mark a fresh orange as rotten and add it to the queue. And then each time you exit from the for loop, add 1 to the minutes to keep track of each minute that has passed. Now let's go over this more concretely. So this is the same example, just recreated. And yeah, step 1, pre-parse this input. So as we can see, we have 6 fresh oranges. The only rotten orange is top left, so we add its location to the queue, 0, 0. And then minutes is 0 to just start. And yeah, let's run BFS. So the initial length of the queue is 1, which means that our length of the for loop, I guess, so to speak, would be 1. Yeah, and then set I to 0. And so each time you pop from the left, right? So the spot is 0, 0. We can remove this. And now we look at all the neighbors of 0, 0. We see this is fresh, and we add their locations to the queue. So the queue is now 0, 1, and then 1, 0. Step the variable up, and you see that it's not less than the length. So what we do is we have to exit out of this for loop and then add 1 to the minutes. So I'll just make a tally of 1. And then each time we add to the queue, I forgot to do this, but we subtract from fresh. So fresh is now 4 because we made 2 of these oranges rotten. And yeah, we continue our iteration starting from 0. So the queue, we pop from the left. Erase this. Yeah, so 0, 1. Take a look at it. So 0, row 0, column 1. It would be this, and then its neighbors are there's 2 fresh neighbors, so we can make these rotten and add them to the queue. It would be 1, 1, and then 0, 2. And yeah, so now we've processed 0, 1, we can remove it, iterate by 1. Oh yeah, I forgot to make the length too because we had 0, 1 and 1, 0, right? So yeah, so the next spot is 1, 0. Take it out of the queue. So that would be like right here, but there's no fresh oranges to add, so we don't have to do anything. And now we've have to exit because 2 is not less than 2. So the number of fresh oranges is now 2. Number of minutes is 2. And the length of the queue is still 2. So we can just leave that as is. Restart. Spot is 1, 1. So that would be this orange, and we see that it has one fresh one down below it, so we can add it to the queue. That is 2, 1, which is the location of that fresh orange. Decrement fresh by 1. Let's just make this crossed out as red so we know that it is rotten. And yeah, so iterate. So remove this, increase by 1, and now spot is 0, 2. So 0, 2, that's this orange right here. And we see that it has no fresh surrounding oranges, so we can just disregard it. Here, I'll just erase that. And yep. Yeah, so I is now 2, 2 is now less than 2, so what we do now is we increment the minutes by 3, update the length of the queue, which is just 1 now. And I'll actually move this forward so it's a little easier. And yep, redo the same process. So we're looking at 2, 1 now, and see 2, 1 is this. It has one fresh orange to its right, so we add it to the queue. Remove or I guess decrement fresh, and I is now 1, which is not less than length. So what we do is increment the minutes by 1, and oh wait, before we recommence the breadth first search algorithm, we first must notice that we've reached one of our stopping conditions, which is that number of fresh is 0, right? Sorry, I forgot to make this mark this rotten, but yeah, number of fresh is 0. So this means that we must exit the algorithm because we know all of the oranges are rotten now, and we return the value of 4. So the general concept is to use a while loop and then nest a for loop within it. And then each time the for loop ends, you want to increase minutes. That's like the general structure of it. But